Hi guys, welcome to Easy Math.
In this video, we are going to discuss about the next lemma. If I is a homomorphism of G to G bar with the kernel K, then K is a normal subgroup of G. Okay, what is given? Phi is a homomorphism from G to G bar with the kernel K. Then you have to prove that this K is a normal subgroup of G. This K is a normal subgroup of G. For that, we have to prove the following four conditions. Okay, to prove K is a normal subgroup of G, for that we have to prove the following four cases. What are that? First one, K is non-empty. We have to check whether this K is a non-empty set. And second one, whether K is closed. And third one, xy inverse belongs to K. xy inverse belongs to K. These two cases are the proof for the subgroup. Therefore, if K is closed and xy inverse belongs to K means we say that K is a subgroup. Okay. Next, fourth one, you have to prove the normal subgroup. That means you have to check the condition Ax A inverse belongs to K. Here this A element belongs to the group G. A element belongs to the group G and X elements belongs to K. X element belongs to K. Okay. Now first claim, we are going to prove K is non-empty, right? By previous lemma, what is previous lemma? Phi of E is equal to E bar and second one pi of X inverse is equal to pi of X the whole inverse, right? Therefore, by previous lemma, we are taking the first condition, that is pi of E is equal to E bar. Clearly, this E belongs to K, since what is the definition of kernel K? Kernel K means set of all X such that pi of X is equal to E bar, where E bar is the identity element, right? Therefore, this E belongs to K. E belongs to K. Since there is an identity element, there is an element in the set K means we say that K is non-empty. K is non-empty. Next, we are going to prove the second one, that is second claim is K is closed. What is closed? If we are choosing two elements X and Y belongs to K, then xy belongs to K means we say that K is closed, right? Therefore, let us choosing the element X and Y belongs to K. K is the kernel, right? Therefore, the element in the kernel can be written as phi of X is equal to E bar and phi of Y is equal to E bar, where E bar is the identity element of G bar. Okay. You have to prove that xy belongs to K. xy belongs to K. Now, considering the term phi of xy is equal to phi of X into phi of Y. Since phi is a homomorphism of G into G bar. Therefore, phi of xy can be written as phi of X into phi of Y. What is the value of pi of X? E bar. What is the value of pi of Y? E bar. Therefore, E bar into E bar. What is E bar into E bar? Again E bar. Therefore, phi of xy is equal to E bar means xy belongs to K. xy belongs to the kernel K. Hence, K is closed. Now, we have to prove the third claim, that is xy inverse belongs to K. xy inverse belongs to K. Let us take x comma y belongs to K. Now, we are going to prove now we are going to prove xy inverse belongs to K, right? Therefore, we are choosing the element phi of xy bar. Since phi is a homomorphism from G to G bar, this pi of xy bar can be written as pi of X into pi of Y bar. By previous lemma, the second condition is pi of X inverse is equal to pi of X the whole inverse, right? Therefore, this pi of Y inverse can be written as pi of Y the whole inverse. What is the value of pi of X? E bar. What is the value of pi of Y? Again E bar. E bar into E bar the whole inverse. What is the value of E bar the whole inverse? Again E bar. Therefore, E bar into E bar is equal to again E bar. Therefore, this xy inverse belongs to the kernel K. xy inverse belongs to the kernel K. Hence, K is a subgroup. Since K satisfies the closure and this condition xy inverse belongs to K. Since K is closed and xy inverse belongs to K, we say that K is a subgroup. Now finally we have to prove that K is a normal subgroup. For that we have to prove Ax A inverse belongs to K for all x belongs to K and A belongs to G. Okay. Let us choose the element x belongs to K and A belongs to G. If x belongs to K means we know that pi of x is equal to E bar, right? Therefore, since we are going to prove Ax A inverse belongs to K, this phi of Ax A inverse can be written as phi of A into pi of x into pi of A inverse, since pi is a homomorphism. Okay, since pi of x is equal to E bar, we are substituting the value here. Therefore, pi of A into E bar into, this is by using the previous lemma. What is previous lemma? That second condition, that is phi of x inverse is equal to pi of x the whole inverse, right? Therefore, pi of A inverse can be written as pi of A the whole inverse. Here pi of A into E bar means pi of A. Pi of A into pi of A the whole inverse can be written as E bar, since E bar is the identity element of G bar. Therefore, Ax A inverse belongs to the kernel K. Hence, K is a normal subgroup of G. Therefore, for this lemma, K is a normal subgroup of G means you have to check the four conditions. First one non-empty, second one closed, third one xy inverse belongs to K, and fourth one K is a normal subgroup. Okay.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.